Hello everyone. This video is going to be about how to do correlational statistics and scatter plots in SPSS. They're both pretty straightforward and they build on what you've already gotten used to with SPSS. Uh, Before I get into that though, I want to follow the effect size discussion. I thought it was an excellent discussion. I love the examples and I really actually liked my assignment of having you look at the three different kinds of effect sizes that are coming from different sources: Marzano, Hattie, and so I want you to be thinking about, for our face-to-face meeting, um, are there times when those guidelines that I gave you do not necessarily apply or should be thought of a little differently? So when you look at the Marzano effect sizes, I don't remember exactly, but I think they range from 0.15 to zero point 0.3, which would be very low in terms of the guidelines I gave you. But they seem like really important things. So how do you put those two things together, that the effect size is small or very low and very important? Do we need to use effect size guidelines a little bit more carefully than the way I presented them? So I'm kind of hinting that the answer is yes, so I guess the question then is, in what cases or why would you think a lower effect size is a bigger deal than in other cases? All right, so this is the school performance profile. Got the right file here. And the two variables we're going to be using are SPP from PDE data. And by the way, I do believe this is going to be changed coming up in there's going to be a new formula. And economic disadvantage. Right. So to do the correlation, pretty simple. Go analyze, correlate, bivariate, meaning two. Correlating two variables. All right, I have already moved these over, but it works just like any other SPSS dialog box. Move them over to the variables. And I could have a whole list here, but it would give me all the pairs that would be possible from that list because it's only doing two at a time. All right, so I get very simple correlational data. Notice the school performance profile has a correlation of 1 to school performance profile. In other words, it's the same thing. And it doesn't matter whether I look at economic disadvantage in SPP or SPP and economic disadvantage. It's going to give me the same number either way. All right? To run the scatter plot, go to Graphs, Legacy Dialogs, Scatter. I'm going to choose Simple Scatter and have to move over SPP and economically disadvantaged into the X and Y axis. And again, those could be reversed. It's arbitrary in this case. Okay. Not completely arbitrary, really, as I think about it, because we could be hypothesizing, and I think it's actually true, that economically disadvantaged is a cause of the SPP profile. So I guess if I had to make a choice, I would put economically disadvantaged on the x-axis and kind of the output on the y-axis, the SPP. Right, and I get a scatter plot like this. So you should do that and then analyze whether you think that's a significant kind of relationship and whether it fits with the article that I gave you the short article that I gave you to read. All right, I'm going to do the same analysis now with the algebra data. I'm closing this so I don't make a mistake. All right, yes, this is the algebra data. And this time I'm going to use the algebra growth measure and free and reduced lunch. But I'm going to do a similar analysis comparing groups using the free and reduced lunch groups category. All right. First, the correlation. Correlate, bivariate. Already got them in there. Okay. And now I'm going to do compare means. So I'm going to go analyze, compare means. And again, I've already got them in here. Algebra growth measure is my outcome measure, and free and reduced lunch is my independent variable. Right, so I'm really looking at the same thing in two different ways here. The first time I'm looking at how these relate from a correlational perspective, but then remember the free and reduced lunch groups variable is really just this variable but segmented into three groups. And when I look at it that way, I get these kind of data where the low poverty is above the mean by 4.88 and the highest poverty is below the mean by negative 10.2. Those are the averages now, remember that. So my question is, what does the correlational data tell you that the comparison by groups doesn't, or vice versa? What do they have in common? How are they the same? How are they different? I think kind of getting your hands on that or getting your mind around that is going to be very helpful in kind of understanding a number of different things that we'll be doing going through the semester. So I'm going to quickly do a scatter plot here. Right? I got the groups there, which really is something you probably would never do, but I'll do free and reduced lunch, algebra growth measures. Right, so there's a picture. It's not quite the same as the school performance profile, but you might kind of see a line going like this. So it seems like there's some trend there. If I was instead to create the same graph, and again, I don't think you would ever do this, but it's kind of interesting to think about. But instead of using free and reduced lunch, use free and reduced lunch groups. What would you expect to get, and how would that be related to the scatter plot I just showed? I'd ask you to stop the video right here, think about that, and then start it back up and you'll see how it looks. Right, so it's three groups, so it's only 1 point on the chart, and this shows kind of all the cases in that group. And how is this the same or different from this? Right? They really are representing the same situation with the same basic set of data as a starting point. Right? We're going to discuss that in class. I don't necessarily need you to post that online, but I want you to start thinking about how correlation and comparison of means are the same and different. All right, see you in class.